Hey everyone, welcome back to another video about exponentials by Epsolot. So far in our previous videos, we have only been looking at different brackets expressions where the expressions are being multiplied inside the brackets, right? So for example, we saw that what happens if you have a times by b to the power of a square, then we know that we can rewrite that as a squared times b squared, right? But in today's video, we are actually going to look at what happens if you have expressions being added or subtracted, added or subtracted within a bracket, and what happens if that is raised to the power of anything, right? At the same time, what happens if you have a number of exponents within the expression being multiplied with an expression from the outside, and how you would expand those brackets using exponentials. So I'll get rid of these ones. So let's begin. Just like I said, imagine that you have two expressions that look something like this. It's a very standard thing for us we might try to look at, that if you have an expression within a bracket and is being multiplied with another addition from in another bracket, what you need to do is that you need to multiply this expression, this variable, with the first one. Then you do the plus, and then you multiply this with that one. Then you multiply this with that one, and then you multiply this with that one, right? So that means that if you're asked to expand on this huge expression, you end up getting a times c plus a times d plus b times c plus b times d, right? So we're doing that in orderly fashion. So you multiply this variable, this one remains fixed, and this one has to be multiplied with each variable within the expression within the bracket. At the same time, then this variable needs to be multiplied with every single variable within the bracket. It does not matter if they're being added or they're being subtracted or they're being multiplied. You have to multiply that with each and every variable. Just like that, if you had even like additional variables, then you will just do that with each and every one of them. Now, that's the basic theory behind it all. And now let's try some examples where you actually have exponentials outside the brackets. Let's start off with a very simple one. Let's say you have x to the power of 3, and within the brackets you have x squared plus 1, right? So now, since this one is on the outside and you have the brackets, and then you have an expression within, you need to multiply this one with each and every variable. That means that you need to multiply this with this one, and then you need to multiply this with that one. But the index law remains the same, that you can only add or subtract. You can only add the exponents as long as the base is the same. So since the base is the same for the first one, then I can rewrite this as x to the power of 5. Plus this one then ends up becoming x cubed. Why? Because there's a 1, but we never really write the 1. So that becomes that. And now let's take an additional example, an example that looks more like that one. So let's say you have a cubed plus 1 times by a squared plus 1. Right? And then what you need to do is that we say a cubed times by a squared. So I'll write down all the expressions so it's easier for you to say, plus a cubed times by 1 plus, and now we are done with the a cubed, so now we move on to the 1. Then 1 times by a squared plus 1 times by 1, right? Now since the base is the same, so I can rewrite this as a to the power of 5 plus a cubed plus a squared plus 1. So that's how you normally expand the two brackets or two expressions within the brackets. Now let's take another example. Let's say In another scenario, you have an expression that looks 3 to the power of x plus 1 to the power of a square. Now, if you end up getting an expression that looks like this one, then the same rules apply as it does with the numbers. Because remember, if I write 3 squared, what does it mean? It means 3 times by 3. That means that this base is being multiplied by itself 2 times. So just like that, if I have a plus b squared, then it actually means a plus b multiplied by itself. So a plus b multiplied by a plus b. So coming it down to this expression, then we say 3x plus 1 multiplied by 3x plus 1. And that, my friends, is 3x plus 1 brackets squared. Then you do 3x multiplied by 3x plus 3x multiplied by 1 plus 1 multiplied by 3x plus 1 multiplied by 1. Then what you get? Then you get 3 to the power of a 2x. Why? Because the base is the same, so we can add the exponents, plus 3x plus 3x plus 1. And that's it. And then what you can do is that you can, because you know that there is a 1 being multiplied with both of them, right? So we can write 2x plus, we can factor out the 3x with a bracket of 1 plus 1 plus 1. And then you end up getting 2x plus 2 multiplied by 3x plus 1. What this number means is that there are 3 to the power of x being added with each other. So that's why you put a 2 there, so 2 multiplied by that expression, and then you can simplify the expression from this to this. So the main takeaway from this example, of course, is that if you have a bracketed expression raised to the power of 2, that means that that expression will be multiplied with itself. But let's take the very last example. Here we go. So let's say you have an example that looks x plus 2x multiplied by x squared minus 2x. So now you see the expressions are not the same. Why? Because we have a plus here and we have a negative here. But the same rules apply. It doesn't matter. So it will be x squared plus x squared plus x squared multiplied by now negative 2x, right? Plus 2x multiplied by x squared plus, now plus a positive multiplied by negative, that gives you a negative. So we can also just write it as, or sorry, we can just do it like 2x multiplied by negative 2x, right? So you end up getting 4 expressions now. So you have, this is the first one, that's the second one, that's the third one, and that's the fourth one. Then what you do is, then we have to simplify it. Then you write x to the power of 4. So far, so good. Now we can simplify it even further. Why? Because the base is the same x, and there's an x there. But since there's a negative, so this becomes a negative. Then you write a 2 times by x to the power of a cubed. In this case, we have exactly the same expressions, but in this case, it will be 2 plus 2x cubed plus, now you have a 2x being multiplied with a negative 2x, so my apologies, there will be a negative there, negative, and then 2 multiplied by 2, that's 4, and then x times x, that will be x squared. Now since these two expressions are the same, but one of them is a negative, one of them is a plus, and just like how plus 4 minus 4, you put them together, you get 0, but they will cancel each other out. So you get x to the power of a 4 minus 4 times by x squared. So you see, so that is the expression that you end up with. So these were the examples that we wanted to look at with the expansion of using exponential expressions. But it's always a good idea if you have a problem that you're trying to solve. It's always a good idea to do it this way. That means that you first write out the expressions, you multiply, expand all of it in this step. Make sure that you make the pairs that you have to make, and then you simplify it, and then you come down to the final solution. But of course, if you have had enough practice, there is an easier way to remember the simplification method, and I'll show you right here. There are these general equations that you can remember, because if you have an expression that looks something like this, then the final expression will of course look something like this. Oops, sorry. I'll rewrite this one. My apologies. Your final expression will look something like AD plus BC plus BD, right? On the other hand, if the two expressions that you're working with looks something like this, so one of them is a positive, the other one is a negative, then your expression will actually, and the final expression should look something like this. If you have an expression that looks something like this, that means that you have an expression being multiplied by itself, then you should get a squared plus 2ab plus b squared. And if you have the same expression but you have a negative in the middle and it is raised to the power of a 2, then you end up getting a squared, a negative 2ab plus b squared. So in reality, if you can somehow memorize these expressions, or not even memorize them, but you have them written down, so every time you get any expression that might look like this, then you can just replace the a's and the b's and the c's and the d with the actual variable, and you would have your final answer right there and then, instead of having to do all the stringent calculations that we have done so far. And to show you, for example, we have a plus b squared. It should give you a squared plus 2ab plus b squared. We have done an example where we did right here. So this is our a value, that's the b, and then that's the square. And you end up getting a squared, right? There's a 2 there now, plus 2 times by a times b. Luckily for the b was 1, so you end up getting 3x times 1 plus b squared, so that's 1 squared. At the same time, for example, in this case, this one is very straightforward because you have to multiply these variables, each and every one of them. On the other hand, if you have a positive and a negative, just like we did right here, then you end up getting a squared minus b squared, which you can see fits exactly, because x squared squared is x to the power of 4 minus 2x, that then gives you the 4x squared. You see, but I would highly suggest that if you are just starting off with expanding this bracket, especially with exponential equations, it is always a good idea to actually do it yourself. That means that you take the long way. It might take you maybe 30 seconds extra, but you are pretty sure that you're doing it the right way. And if there are any errors, then you can find them along the lines. But of course, once you have had enough practice, then it's also a good idea sometimes to use these definitions when you're working around with the expansion of brackets. And that was all for this video, and I really hope that you enjoyed it. And if you did, then do remember to subscribe to the channel and stay tuned for our next videos in the exponential chapter. Thank you, and have a great day.